Okay, so in terms of domain for this course, we're pretty much just looking at two things. One is if we have division by zero, so something with a denominator, and the other is if we have a square root function. So for division by zero, all we gotta do every single time is just take that denominator and then set that equal to zero and solve. And that's gonna be the value that if I plug that back in here, would make the denominator come out zero, and then that would be undefined. For the roots, it's a little bit different. For that, we want to have the stuff under the radical has to stay greater than or equal to zero. And the reason is I could take the square root of zero, square root of zero is zero, square root of one is one, square root of anything positive has a result. But if you try to take the square root of a negative number, like the square root of -4, say, there's no number that you multiply itself that makes -4. You'd have to have a +2 and a -2 to come up with a -4. So you can't take the square root of a negative number. So that's why we have this little rule right here that we just take the stuff under the radical. The 7 doesn't matter at all. It's just the stuff under the radical, and we set that greater than or equal to 0, and then solve it out. So here we get the x's have to be greater than or equal to 2 for this one. In this example, there's a negative on that x, and I did that on purpose just to remind you that when you divide by a negative with an inequality, it flips the direction. This one's a little more straightforward. So x's are greater than or equal to 2, so in interval notation that's going to look like a 2, and if you think about if interval notation is all hard for you, think about what the number line would look like. X is greater than or equal to 2 would be a solid dot and going this way. So our point farthest to the left is 2, bracket, because we're including, because we have an equals. If there was no equals, I'd have a parenthesis and an open dot. So 2 to infinity would be my interval notation solution set for the domain of that. Hopefully that helps.